Welcome dear students to the online class on determinants. Okay, so before we do determinants, let's talk about two different kinds of matrices. That is, number one is 2 cross 2 matrix. So let me take a 2 cross 2 matrix. So you call this as A11, A12, A13, A21, A22. So this is my 2 cross 2 square matrix, right? And let me take one more matrix, and this time I am going to take square matrix of order 3. That is, I am taking 3 cross 3 matrix. So let me take the matrix to be okay. So you see here that I've got two different matrices, right? So if I call this as A, okay, and similarly let me call this as A, then the determinant of this matrix, that means you will be able to find determinants only for square matrix. Remember that, okay? So you cannot find determinant of rectangular one. You have to have same number of columns and same number of rows for the matrices in order to find the determinant. Okay, so in your syllabus you are going to deal with the matrices of order 2 cross 2 and 3 cross 3 in order to find the determinant. Now let's see how do we find determinant of 2 cross 2. Okay, so the rule is very simple. Okay, so what you need to do is you need to follow this direction and you have to multiply them. Okay, so that means determinant of A, okay, so determinant of A can be written as this one. Okay, so this line represents determinant. It's similar to modulus sign. Okay, so we have A11, A12, A21, A22. Okay, so the rule is, as I said, you have to follow this direction. So follow this direction and multiply. So you get A11, A22, A11, A22. Now you have to follow this direction and we have to multiply them. So you have A21, A12, or whatever, whichever you want, right? A12 or A21. Okay, now in between you always need to write minus sign. That's all for your 2 cross 2. But for your 3 cross 3, for your 3 cross 3, you have got a different technique. Okay, so for that, what sign you have to follow is, you have to follow plus here, you have to follow minus here, you have to follow plus here. Okay, and what you need to do is very simple. Okay, so A11, okay, so the determinant of A, as you all know, is written as determinant of this. Okay, right? So we have A11, A12, A13, A21, A22, okay, so basically you want to evaluate this determinant, isn't it? Right? So as I said, you have to follow this sign. Okay, so in that case, what am I going to do is, so plus A11. Okay, so first we'll write all the elements of first row. Okay, you have to write all the elements of first row. So let me write all the elements. So A11 will have sign plus, so A11 is there. A12 will have minus sign, okay, so minus A12, and A13 will have plus sign, A13. Okay, now after that what you need to do is you have to write 2 cross 2 determinant here. Okay, so 2 cross 2 determinant, 2 cross 2 determinant. Now what are those 2 cross 2 determinant? Let's see. So A11 is there. Okay, so cover this row, cover this column. Whatever numbers are left, that will come in this determinant. Okay, so that basically you get A22, A23, A32, A33. Okay, right? All right. Now cover A12. Okay, so A12 is in this row and this column. So what are the number left? So you have this, this and this, isn't it? So all those numbers will come in this determinant. So you have A21, A23, A31, A33. Okay. Now similarly, A13 is present in this row and this column. So if I cover this row and this column, I am left with these 4 numbers. So those 4 numbers will come in this determinant. So you get A21, A22, A31 and A32. Okay. Now after this, you know, right, how to evaluate this 2 cross 2, because we have just now seen how to evaluate, right? Okay. Now fine. So now my question is this the only way to evaluate, or do we need to follow only this sign convention? No, that's wrong. Okay, so we can have one more technique. What you can do is, instead of following this first row, you can follow first column also. Okay, or else if you don't want to, then you can follow the last row, okay, or the last column. Okay, so the rule is going to be same. If you are following this first column, okay, you have to write down the element of first column, then cover those elements, and whatever numbers are left, those will come in this determinant. Okay, so this is how we evaluate 2 cross 2 matrix determinant and 3 cross 3 determinants. All right. Now at the same time, we'll learn about minor and cofactor. Okay, so listen to my words very carefully. Minor is also known as, or written as, Mij. Okay, now in order to find Mij, you know, I stands for row position and J stands for column position, right? So basically what you need to do is, if you are asked to find, let's say, M12, okay, so M12 means, you see, first row, second column, right? Okay, so this minor is nothing but a determinant only. Okay, minor is a determinant. Now this determinant is obtained by removing the first row and second column. So remove first row and second column. So I have removed this. So what do we get? We get these remaining numbers, isn't it? So this is known as your M12, that is minor of 1, 2. First row, second column. So that means the remaining numbers are A21, A23, A31, A33, right? So this is your M12. Okay. Now if I ask you to find M23, second row, so remove second row is gone. Okay, and you have to have third column, so we will remove third column also. So second row and third column is removed. So whatever numbers are left, if I put them in a determinant, that is A11, A12, A31 and A32. So if I put them in this determinant, this becomes the minor 2, or minor 2, 3. So this is how we find minor. Now what is cofactor? Okay, so having understood or having learnt about the minor, cofactor is easy. So cofactor is written as Aij. So formula is very simple. Aij is equals to, the cofactor is found using this formula, minus 1 to the power I plus j, okay, Mij. Now you know how to find Mij, isn't it? Now you know the value of I and j. Put them over here and put the value of Mij. Whatever number you get, that will be your Aij, that is the cofactor. Okay, so having understood this much, let's see a few problems based on these concepts. Okay, now let's evaluate these determinants. Okay, so let's observe this very carefully. Although now you are quite confident, but sometimes you may end up making mistakes, right? So sine 30 degree, what is the value of sine 30 degree? It's 1 by 2, right? Cos 30 degree is root 3 by 2. Sine 60 is root 3 by 2, so that's why it is minus root 3 by 2. Cos 60 degree is half. So I told you the direction is, first multiply this, So you get half into half is 1 by 4. Sign will be minus here, isn't it? So now root 3 into root 3 is 3, by 2 into 2 is 4, but here we have minus also, so we have minus. Is that clear? So multiply, so 1 by 4, minus into minus becomes plus, so it is 3 by 4. So you know LCM is 4 and this becomes 1 plus 3, so this is 4 by 4, that's why your answer turns out to be how much? 1. Okay, isn't it very simple, right? Okay, now let's observe the second one. Okay, so as I told you, follow the sign convention, plus minus plus. Okay, so let's write these things first. Okay, so you have this is equals to 3, so you have minus of minus 4, and at last you have plus 5. Okay, so you have plus 5 out here. So let me draw a margin out here. Okay, so this is plus 5. Okay, now I told you remove this row, remove this column, so you get 1 3. Okay, so let me write that 1 3 minus 2 and 1. Okay, similarly let's do the same. So when you take minus 4, the minus 4 is there in this first row, second column, so the numbers left are 1 minus 2 to 1. Okay, so at last we have plus 5, isn't it? So plus 5 can be written as, okay, so plus 5, when you remove this row and this column, you have 1 1 2 3, right? So this is what we get. Now next is very simple, you just need to evaluate, right? So 3, so 3, so let's multiply. So 1 into 1 is 1 minus, so 2 into minus 2 is minus 6. So we have minus 6, minus into minus becomes plus 4. So 1 into 1 is 1, 2 into minus 2 is minus 4, but we have to write minus sign here, right? Plus, so 1 into 3 is, okay, so 5 is also there. So 1 into 3 is 3, minus 2 into 1 is 2. Okay, yes? So we have 3 into, okay, so evaluate this. So 1 minus into minus plus 6. So 1 plus 6 is 7. So 3 into 7 plus 4. 1 minus into minus is plus. So 1 plus 4 is 5. So 4 into 5 plus 5 into 3 minus 2 is 1. Okay, so let's see how much is this. So this is 21 plus 20 plus 5. So let's add them. So you get 46. So that means the value of this determinant turns out to be 46. Okay, next let's observe this. Now when you see such kind of cases, no, okay, where you have 0 2 0, okay, either it can be here also or here also. So in such case, what you need to do is you have to take this way. Is that clear? Since 0 is here, so that's why I'm going to work this way. You can work with this way also, that's also fine. But when you have 2 zeros in the extreme row or extreme column, so that time you have to take that particular column or that particular row. Okay, so you have zeros out here, isn't it? So that's why if I consider this, what I need to do is I write plus of minus 1, right? So plus of minus 1, when you do that, so when you remove this row and this column, the remaining numbers are 5 minus 4 32 0 20, right? Now you have to take minus 0 and some determinant will come, isn't it? And that is, remove this and this, so you get 31 40 0 20. So 31 40 0 20. Now you have plus 0 again, so plus 0. Now remove this and this, you get 31 40, so you get 5 minus 4 32, right? Okay, now we have plus into minus is minus, so let's multiply. 5 into 20 is 100, minus 0 into anything becomes 0. Now, do I need to evaluate this? No, because you see there is 0, so this entire thing becomes 0, right? Similarly, this is 0, so I need not calculate this. So automatically this becomes minus 0 plus 0. This is minus 0 plus 0, right? Okay. Now, how much is this? This is just minus 1 into 100, which is minus 100. That means the value of this determinant turns out to be minus 100. Isn't it very simple, right? If you have two zeros, your work becomes very easy. Alright. So, you may pause the video and note down your solution. Now, let's take problem on finding minor and cofactor. Right. So, all of you know that in order to find the cofactor, you definitely need minor, right? So, first let's find, or rather let's see what we are asked to find here. So, you have to find the cofactor of A12. So, A12, remember, first row, second column. So, first row, second column means you have to find the cofactor of this. Okay. So, remember the cofactor of A12 is basically what? It is basically A12. Okay. So, you have to find the value of A12 and you know that it is equal to minus 1 to the power I is 1 plus j is 2 mij, right? So, basically first let's find what is M12 here. Okay. So, we have M12. So, remove first row and second column. So, first row and second column is gone. So, the remaining numbers are 6, 4, 1, minus 7. 6, 4, 1, minus 7. So, let's evaluate this. So, do the cross multiplication. 6 7s are 42 with sign is minus. So, minus 42. So, 4 1s are 4, sign comes minus here, right. So, how much is this? Minus 46. Okay. So, therefore, the cofactor A12 as per the formula is minus 1 to the power 1 plus 2 M12. Let's put the value. Minus 1 to the power 1 plus 2 is 3. M12 is minus 46. Now, all of you know this is minus 1. So, minus 1 into minus 46. So, multiply this. Minus into minus becomes plus. So, that is why your answer will be 46. Okay, that means the cofactor of this is 46 in this case. Let's take that problem. That problem and this question, see the determinants given here are same. But here you need to find this particular thing. What is A32? So, you know A32 is nothing but minus 1 to the power 3 plus 2 M32, right? Shall we find this? Okay, so M32. So, third row, second column. Third row, second column. That means remove third row and second column. The remaining numbers are 2, 5, 6, 4. Let's evaluate this. 4 2s are 8 minus 6 5s are 30, right? So, it is minus 22. So, therefore, your value of A32 will be equals to minus 1 to the power 3 plus 2 M32, right? Isn't it? So, let's calculate. So, this is minus 1 to the power 5, M32 is minus 22. Now, this is again minus 1 into minus 22. So, this is equal to 22, isn't it? So, I got A32, but we are asked to find, remember, A32 into this, right? So, therefore, we have A32, this one, okay. So, you know A32 is this one, isn't it? So, the value of A32 is 5 into what is capital A32? The cofactor of this is how much? 22, right? So, let's evaluate this. So, this will be equals to 110. That means your answer for this is equals to 110. So, pause the video and note down your solution. Let's observe this question now. Find the value of x if x is a natural number and this happens. Very simple question again, 2 marker. Okay, so let's see how to do this. So given is ax plus 3, determinant of x plus 3 minus 2 minus 3x, 2x is equals to 8, and x is a natural number, remember. Okay, so you know this 2 cross 2, so it's easy, right? So it becomes 2x into x plus 3 minus into minus is plus, so 2 into 3 is x is 6x. So this is equals to 8. Okay, so we have, okay, first and foremost, let's divide throughout by 2, because see, every term is divisible by 2, right? So when you divide by 2, so you get x into x plus 3, so this becomes minus 3x, this becomes 4, right? Open the bracket, so you get x squared plus 3x minus 3x is equals to 4, right? 3x and 3 gets cancelled, so sometimes if it's not cancelling, then bring this out here, you get a quadratic equation and solve it. Okay, so here we get x squared is equal to 4, and therefore the value of x will be plus minus 2. Okay, now although we got the value of x, right, but here remember x is a natural number, isn't it, right? So you have to write at last, as x belongs to natural number, set of natural number, so therefore the value of x will be, out of plus minus 2, your value is only 2. Okay, so pause the video and note down your solution. Now let's observe this particular question. So find the value or values of x from this when x is belonging to set of integers. So given is given determinant of 2x 3 minus 1x is equal to 3 1x 3, right? Now earlier in matrices, what we used to do is we used to take this equal to this, right? That's how we used to do. But in case of determinants, you are not allowed to do that. Okay, be very careful. If it comes in the exams, you have to be careful. Okay, so in such questions, what we need to do is we have to evaluate the determinant. Do the cross multiplication. So 2x into x is 2x square, minus 1 into 3 is minus 3, in the middle comes sign minus, equals to 3 3s are 9, minus x into 1 is x. Okay, so this is equals to 2x square, so this is minus plus, right, plus 3. So bring this out here, so minus 9 plus x equals to 0. So from here you get 2x squared plus x minus 3 equals to 0, isn't it? So let's do middle term here. So we have 2x squared. Now 3 2s are 6, right? So we have to separate, here we have got 1, right? So we have to separate this. So since you have minus, write minus here. So separate 1 into 2 numbers, so that the difference of those 2 numbers turns out to be 1, and the product of those 2 numbers to be 2 into 3, that is 6. Obviously the numbers will be 3 minus 2. So you have minus 3 equals to 0. Okay, all right, so open the bracket. So you have 2x squared plus 3x minus 2x minus 3 equals to 0. You see x is common here, right? So x is common means you get 2x plus 3. Here minus 1 is common, so you get 2x plus 3 equals to 0. So take out 2x plus 3. So when you take out 2x plus 3 from here, you get x here, and when you take out 2x plus 3 from here, you get minus 1 equals to 0. So this means either 2x plus 3 is 0, or you have x minus 1 equals to 0. So from here the value of x turns out to be minus 3 by 2, and from here you get the value of x to be 1. Now since the question is saying that x is an integer, can this be my answer? No, because minus 3 by 2 is not an integer, right? So this cannot be integer. Can this be my answer? Yes, because 1 is an integer, right? So as x belongs to z, sometimes you may see I also stands for integers. So therefore we have x is equals to 1. So the value of x will be equals to 1. Okay, fine. So we will do only this much for today. Okay, so we will continue the very same chapter in the next class. With this we close. Thank you very much.